Elon Musk's SpaceX ignites the future with Ship 35's test for Flight 9. Will Crew Dragon's next mission soar? And can NASA's Psyche overcome its challenges? Join us to explore. S35's static fire tests, SpaceX is steadily progressing toward Starship Flight 9, with recent milestones marking critical steps in the pre-launch campaign. It's been nearly a month since Booster 14's static fire test, and attention has now shifted to Ship 35 as it enters the spotlight. By the early hours of April 29th, just after Ship 36 returned to the production site, Ship 35 made its way from Mega Bay 2 to the Massey's test site. This move came about 2 weeks after S35's Raptor engines had been delivered and installed, signaling readiness for testing. Later that day, S35 underwent an initial venting procedure, a small but necessary step to prepare the ship's tanks and plumbing for full-scale operations. That evening, teams performed a tank system check to verify fuel flow and pressurization systems. These preparations culminated the following night, April 30th, in the ship's first static fire test. Under cover of darkness, a brief flash of flame lit up the launch stand, followed by a modest plume of smoke. The low intensity indicated a single-engine ignition, later confirmed by SpaceX. The test involved only limited propellant loading, just a partial fill of the methane tank and less than a third of the liquid oxygen tank. Footage released on SpaceX's official X account showed one sea-level Raptor engine igniting for approximately 7 seconds, likely reaching its maximum thrust of 230 tons. The ignition and shutdown were both smooth and controlled, suggesting a fully successful firing. SpaceX commented on the event, stating, "The Starship preparing for our 9th flight test completed a single-engine static fire demonstrating an in-space burn. This milestone is particularly important because it serves as a test for mid-flight engine reignition, a critical maneuver that will allow Starship to perform complex in-space burns." While this was previously demonstrated on Flight 6, the company was unable to replicate the feat on Flight 7 and 8. This test is a step toward ensuring reliability in that capability for Flight 9. However, this is only the beginning of S35's test campaign. To move closer to launch readiness, SpaceX must also complete a 6-engine static fire involving all 3 sea-level and 3 vacuum Raptors. The company attempted this next step on the afternoon of May 1st, initiating fueling and venting procedures. But after some progress, the system was detanked, indicating an aborted attempt. A second try was hinted at shortly after, based on temporary road closures posted for May 2nd and 3, likely to support movement between Massey's and the main factory. Another sign of ongoing operations. The 6-engine test was eventually carried out as scheduled. All engines were ignited simultaneously, generating more than 1,400 tons of thrust. The firing lasted up to 30 seconds, shorter than the 1-minute test achieved by Ship 34, but long enough to test operational limits. Notably, during the burn, the engines appeared to vary their thrust levels, simulating the adjustments needed for complex in-flight maneuvers. The flame trench system at the Massey's site played a key role in dispersing the intense heat and pressure during the event. Once again, the test took place at night, but this time a powerful exhaust plume could be seen shooting from one side of the stand, a sign of the full power of the static fire. Following this static fire milestone, SpaceX is expected to carry out several additional tests on S35 to ensure mission readiness for Starship Flight 9. These may include further single-engine firings involving different combinations of sea-level and vacuum Raptors, as well as tests using varied propellant levels. Such trials are vital for uncovering potential issues under diverse conditions and for fine-tuning system responses before launch. Once these final tests are completed, S35 will be transported back to Mega Bay 2. There, it'll undergo a thorough inspection process focusing on key systems such as the engines, heat shield, and fuel tanks. Any signs of wear or damage will be addressed during this phase. Following checks, technicians will install the flight termination system and the payload. These steps also involve continuous monitoring with meticulous verification before, during, and after installation to guarantee the vehicle is in optimal condition for integration and flight. Afterwards, S35 will be rolled out to the launch pad, where it'll be paired with Booster 14 for final integration, testing, and pre-launch operations. At this point, both stages will be connected, and systems such as avionics, hydraulics, and fueling interfaces will be assessed for compatibility and reliability under flight conditions. Now comes the big question: when will Flight 9 launch? Based on the current pace, we can make an educated guess. Booster 14 has already completed key steps, including the installation of the hot staging ring and likely the flight termination system, meaning it's essentially ready to move to the pad at a moment's notice. In contrast, S35 still has to go through several checkouts and installations, which could take about a week or more, likely from May 3rd to mid-May. After that, assuming SpaceX performs a wet dress rehearsal, which would add a few more days, the launch could occur around May 20th. While this may feel like a long wait, especially as it'll be more than 2.5 months since Flight 8, it's important to remember that precision and safety are the priorities. A longer preparation cycle means SpaceX is being cautious, working to ensure a successful mission rather than rushing to meet a schedule. Given the ambitious goals for Flight 9, this careful approach is fully justified. In short, we're getting very close to the next big step in Starship's journey. If you're as excited as we are, comment "Let's go 9" to show your support for SpaceX. Don't forget to like the video and subscribe to stay updated on Starship and other exciting developments in the aerospace world. Your subscription also helps us grow our community. Thank you for being part of the journey. Axiom 4's schedule now. Let's take a look at the latest developments surrounding the upcoming Crew Dragon mission. Axiom 4, AX4, a private spaceflight organized by Axiom Space in partnership with NASA and SpaceX. On April 29th, NASA and Axiom officially announced that AX4 is scheduled to launch at 10:03 p.m. Eastern on May 29, 2025. This mission marks Axiom's fourth crewed mission to the International Space Station, ISS, and continues the company's goals of expanding global access to space through commercial partnerships. In preparation for the launch, the AX4 crew has undergone extensive training, including rigorous evaluations using Axiom Space's next-generation spacesuits designed for enhanced comfort and flexibility in microgravity. The training campaign was a success, as confirmed by SpaceX, which stated on X that the AX4 crew had recently completed training in California ahead of their mission to the ISS. This mission features a diverse international team of astronauts, with representatives from the United States, India, Poland, and Hungary. The crew will be led by Peggy Whitson, a record-setting former NASA astronaut and Axiom's director of human spaceflight. This will be her 5th trip to space and her 2nd with Axiom. The other 3, Shubhanshu Shukla, Swawosh Uznansky, and Tibor Kapu, each represent nations participating in a crewed orbital mission with Axiom for the first time. Axiom Space takes pride in this growing international collaboration. Lucy Lowe, Axiom's chief scientist, highlighted that these missions have now represented 11 different nations, emphasizing that they are creating opportunities for countries previously excluded from direct access to space. The AX4 mission will also support a record-setting 60 science investigations involving researchers from 31 countries. These experiments will explore a wide range of objectives, including the impact of microgravity on cognitive performance and motor function, radiation exposure monitoring, and environmental data collection aboard the ISS. Collaborative studies, with both India's ISRO and Europe's ESA, are also included, reinforcing the mission's global significance. Once in orbit, the AX4 crew is expected to spend 2 weeks aboard the ISS. Their stay will not only facilitate important scientific work, but also provide operational experience that will inform the development of Axiom's own commercial space station in the near future. For SpaceX, this will be the 3rd crewed launch of the year, following Crew 10 and Fram 2, with several more missions scheduled before the year's end. Crew Dragon is on track to achieve its busiest year yet, further reinforcing its position as one of the most reliable and versatile spacecraft in the industry. As the countdown continues, all eyes will be on this important step forward for commercial spaceflight. Psyche spacecraft's problem now. Let's shift gears for an important update on NASA's Psyche mission. On April 29th, NASA reported an issue with the spacecraft's solar electric propulsion system, which plays a critical role in guiding Psyche to its target, a metal-rich asteroid located in the asteroid belt. The spacecraft, which launched aboard a SpaceX Falcon Heavy in October 2023, is currently about 238 million kilometers, 150 million miles from Earth. According to NASA, the anomaly involves a drop in pressure within the xenon fuel line that supplies the electric thrusters. On April 1st, the onboard systems detected that pressure had fallen from 36 psi to 26, prompting mission controllers to shut down the thrusters as a precautionary measure. The initial analysis points to insufficient pressure to effectively push xenon into the propulsion system, hindering thrust generation. To understand the issue more clearly, it helps to know how the propulsion system works. Psyche relies on solar arrays to gather sunlight and convert it into electricity. This electricity powers an ion propulsion system, which creates an electromagnetic field that expels charged xenon atoms, producing gentle but efficient thrust. It's a cutting-edge approach that allows spacecraft to reach distant destinations, using far less fuel than traditional chemical rockets. However, this is the first time such a system is being used beyond lunar orbit, adding a layer of complexity. With the thrusters offline, engineers are now evaluating options. NASA mentioned, the spacecraft has two identical xenon fuel lines, and the team may choose to switch to the backup line to restore propulsion. For now, thrusting has been deferred while investigations continue. The temporary loss of propulsion has raised some concern, particularly about maintaining the mission timeline. Psyche is scheduled to fly by Mars in spring 2026 for a gravity assist and eventually arrive at the asteroid Psyche in 2029. If the issue persists beyond mid-June, there could be impacts on the mission's path or timing. Despite the setback, NASA's engineering teams are well equipped to tackle the challenge. Their next steps will be crucial in ensuring that Psyche stays on course. As always, we'll be keeping a close eye on developments, so stay tuned to see how NASA responds and what solutions they implement to get the spacecraft back on track. This has been our update on SpaceX and NASA's latest developments. Don't forget to like the video and subscribe to stay up to date with us on the latest details of SpaceX's journey and other advancements in aerospace. Thank you for tuning in, and remember, curiosity, imagination, and inspiration will always follow you as long as you keep looking up.